My name is Dr. WK1. I'm here to handle some of the first classes. I'm to handle physics now. And we're going to do the physics one, that's the physics 101, yes. That general physics 1, we're going to do that together. And we'll be talking, let me rule out the course content, which I hope by now you should be having too with you. The course content so that you will have it with you. The title of the course is General Physics 1. General Physics 1. And what are we going to treat there? We will be treating in classical mechanics, space and time, straight line kinetics, motion in a plane, forces and equilibrium, experimental basis of Newton's law, particle dynamics, universal navigation, collisions, and conservation laws, work and potential energy, vibrational motion, conservative forces, inertial forces, and non-inertial frames, central force of motions, rigid bodies, and rotational dynamics. Those are the items we are going to cover in this course, General Physics 1. But today, being our first class, I'm going to do the introduction of the course, and we're going to learn the basics we have had before now. We're going to learn what we have had before now. So let's look at the classical mechanics overview. Classical mechanics is a branch of physics that deals with motion objects. Hello, can you mute yourself? Student, can you mute yourself? Thank you. We're discussing classical mechanics as a branch of physics that deals with motion of objects and the forces acting on them. Every object has a tendency to move, but there are forces acting on them. We'll be studying that. And that is a great concept that will lead us to the in-depth of the methods we want to treat. It encompasses several fundamental concepts and laws that describe how objects move and interact. Yes, I know you will have had Newton's law of motion and so on. You will have had laws of elasticity and so on. But don't worry, we're going to go in depth into them and they're going to help us. What are the fundamental concepts of classical mechanics? What are the fundamental concepts? The first of them is kinematics. The first of them is kinematics. The second one is dynamics. And the third one is statics. Kinematics, dynamics, and statics. Kinematics, dynamics, and statics. Let me address the first one, which is kinematics. Kinematics describes motion without considering its causes. Listen carefully. Kinematics describes the motion without considering its causes. That is concerned primarily with the motion of an object, but it does not concern itself with the causative factors that actually engineered that such motion. That's kinematics. But dynamics, what does it mean? Or let me go back to kinematics. That kinematics, if I have an object, and that object, the object, let's assume The object is moving. The object is moving. It's moving. Kinematics is concerned about how this object moves from here to here. But nonetheless, it's not concerned itself with what causes that movement. So purely the movement is the concern of kinematics. Let's look into dynamics. Dynamics describe the motion and the forces that causes it. The dynamics describe the motion and the forces causing it. That means dynamics does not discuss only the motion. It also discusses what is causing that motion of the objects. So if you're talking that an object is to move from point A to point B, yes, that is the movement. But what is making that object to move from point A to point B is also a study point in dynamics. Let's now look at statics. Well, simply statics, from the word statics, even literally, we know that statics study forces in equilibrium. Statics studies forces in equilibrium. Before you can achieve equilibrium, there are forces involved. I'm going to demonstrate to you something, and you see how we achieve equilibrium. Even three persons who are not using any seat to sit down and they're comfortable. Hello?
Sir?
Yes, please.
Yeah, you're a bit fast. We can't really get you.
Don't worry. If I'm faster, I'm going to give you every study material, nothing hidden. That's clear? But I'm going to slow down.
Okay, sir.
I'm going to slow down. Why? I'm going to slow down. Two, you are going to get all my notes. I'll send them across this board. Are you
All right, thank you, sir.
My notes are
Yes, sir.
I will give them to you in bits. Only that I will not do all of them at the same time. I'm going to give you all my notes, but I'll give that to you per class so that you can be attending the classes. Is it good by you? Is it good by you?
Yes, sir. It's okay.
Thank you.
Yes, sir.
Thank you.
All right, thank you, sir.
So, statics only studies the forces of equilibrium. It studies the forces of equilibrium. Now, I've given you the three fundamental concepts that is making classic mixes to be unique. I've mentioned kinematics. Are you there with me? I've mentioned kinematics. I've mentioned kinematics. I've mentioned dynamics. At the same time, I've mentioned statics. I want to write them out for you so that I can actually note them. I'm waiting for the whiteboard to come up so that I can write some things for you. Let's see. The first one I told you is kinematics. Let me go with something that's smarter. Kinematics. Kinematics like dynamics. Kinematics. It's fine. Dynamics. and statics. These are the three concepts that's actually making out classical mechanics. These are three concepts: kinematics, dynamics, and statics. And I've been able to describe the three of them. So now, let's now go into details of each of them. Let's look at kinematics now. Key topics in classical mechanics. First one I'm going to be considering is kinematics. Another kinematics, we're looking at scalars and vectors quantity. We have scalars and we have vectors. What are scalars? Scalars are quantities with only magnitude. Scalars are quantities with only magnitude. Can you get that? Scalars are quantities with only magnitude. Example of scalars are speed, distance, and time. Are you with me? Scalars are quantities with only magnitude. Examples are speed, distance, and time. They only have magnitude. Let's now talk about vectors. Vectors are quantities with magnitude and direction. Vectors are quantities with magnitude and direction. It means when you are talking about their magnitude, you must also be concerned at the direction at which that magnitude is moving. Therefore, we can easily say that a vector is a quantity with both magnitude and direction. An example is velocity. Another example is displacement. Another example is acceleration. You cannot describe acceleration in quantity alone. You have to describe acceleration in terms of direction as well. You cannot describe velocity in terms of quantity alone. You have to describe velocity in terms of quantity and direction. So also displacement. A question like this can come up. Say that, what is the major difference between scalars and vectors? What is the major difference between scalars and vectors? I want you to respond, please. I want you to respond. Unmute yourself and respond, please. Unmute yourself and respond, please.
Sir, please repeat the question.
Okay. What is the major difference? Mute yourself and listen. Mute yourself and listen to me. Mute yourself and listen to me. What is the major difference between scalars and vectors? I want you to raise up your hand. Click on raise up your hand so that I'll pick somebody. I will identify you. Raise up your hand if you want to answer the question. Want to answer the question, raise up your hand. You can raise up your hand from the Zoom as well. Don't worry, but I've seen your hand. And this is Elijah Blessing, right? Unmute yourself and go ahead and answer the question.
The difference between the scalar and the vector is the scalar has only magnitude and the vector has magnitude and directions.
Okay. A scalar has only magnitude, while a vector has both magnitude and direction. I love you put it better. Who can put it better for us, please? Unmute yourself now. Unmute yourself and answer the question now. I want another person to respond. Blessing. Go ahead.
Sir?
Thumbs up. Blessing, go ahead. Blessing, go ahead.
The differences.
Hold on.
That's all.
I'm thinking one important phrase so that you not just be repeating the definitions of both scalars and vectors. I said, what is the major difference between scalars and vectors? I'm looking for a particular phrase. Say it. Don't worry, don't be afraid. Just say it anyhow. I'm here to correct you. Blessing, go ahead.
The distance and time is speed, and vectors have velocity, displacement, and acceleration. That means the movements.
You are saying something good, but it is not still very correct. I will only ask you to state the difference, with the major difference between scalars and vectors. Yemi, Yemi, can you go ahead? No, I don't want Emmanuel, Hadassah, put on your
Yes.
hands to answer. I didn't want you to answer.
Okay, difference between
I didn't want
scalar
you
and
to answer
vector.
it. No. Put on your hands. Don't answer it. Thank you.
Okay.
Mute yourself. Emmanuel, mute yourself. Good. Yemi, I want you to answer that question. I'm waiting for Yemi to answer the question. I want Yemi Oduz to answer the question. Yemi, are you there? Yemi, are you there? Okay. What about success? Success, go ahead. Success. Go ahead.
Hello, sir. Can you hear me?
Good morning, please.
Yes, sir.
I've only asked one question, and my question is, what is the major difference between scalars and vectors?
Okay. The scalars has only magnitude.
Say
And
that clearly, please.
say
clearly. And which is success? Go ahead.
Okay, I said of course with only just magnitude without direction. But the vectors is with magnitude and direction.
You are just giving the definition of the two together. It's good, you are correct. But I'm expecting you to answer it better for an examiner, and the examiner may be an international exam. So I want a better answer that will actually prove that you know what you're saying. Well, I want Emmanuel to answer now. Emmanuel? Emmanuel? Okay, if Emmanuel is not talking, Elijah.
I'm here.
Okay, go ahead.
Okay. Scalar has no definite direction but has a magnitude, while the vector has a definite direction and a magnitude.
Correct, you are correct. I only expect, now mute yourself. I only expect you to give it, okay? Elijah, your hand is up. Elijah.
I say scalars describe the motion without form.
So
They
what?
describe without perceiving the motion.
Again?
They describe the motion without considering the motion. That's scalars.
Okay.
While vectors considers the motion and displacements.
Okay, you've done well. You've done well. I only want you to reroute your thinking. I only want you to reroute your thinking. Mute yourself. Mute yourself. Let me now tell it to you. You see, in a situation like this, if you are asked such a question in an exam, it is expected they're going to bring out the uniqueness in either of the two that one does not have. Considering scalars and vectors, only vector has a direction. Only vectors do consider directions, whereas scalars does not consider direction. That is the unique difference. Can you see the way I put it? Can you see the way I put it? Hello?
Yes, sir.
I want your responses. Can you see the way I put it?
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Yes. What you should be bringing out when you are asking to do comparison is you bring out the uniqueness. What you cannot find in others, you bring it out. And that takes that one out. And you are considering it for a major difference. God bless you. Thank you. Let me move forward now. Let's look at motion in one dimension. I want to look at motion. I'm going to give you this note, so relax. You're going to have it. I'm going to give you as will I give you as attachment, or will I give it to you? Don't worry, I'll get that across to you anyway. I'll get to you. Let's look at motion in one dimension. Let's look at motion in one dimension. Are you with me?
Yes, sir.
Motion in one dimension. See if I can have it. Okay, come on. Motion in one dimension. Yes. I want any one of you to describe to me what is a distance. What is a distance? What is the distance? Yeah, go ahead. Describe distance. Your hands up. Want to talk? I want to see your hands up. Go ahead. Raise up your hand. Want to talk? Emmanuel, I'm expecting you to raise up your hand. Describe distance. Distance. Anyhow you want to say it, anyhow you know it, distance. Go ahead. Who wants to raise up his hand? If you're not raising up your hand, I'm going to call you. I'm going to call you. If you're not raising your hand, I'm going to call you. Success. Success. Success.
Yes,
Yes,
sir.
sir.
What is success?
Yes, sir.
Yes, sir.
Describe distance.
Okay.
Elijah,
I think
mute yourself.
distance is
Elijah, mute yourself. Good. Thank you. Success, go ahead.
yes, distance is it has to do with displacement and time,
No.
like the movements from one place to another.
Don't describe distance. What is distance? Literally, distance. Not technically. What is distance? Go ahead. Distance. What is distance? Okay. Literally, when you have two identified positions or points, and there's a connection between those 2 points A and B, that movement, either in a whether straight line or not, is the distance. So I only want you to hear that. What is distance? Not in technical terms, I only want a literal meaning of distance. Cover a distance. You are at point A. An object is at point A and it moves to point B. That means a distance has been covered. An object, let me describe that to you now. Let's go to our whiteboard. Go to our whiteboard. Question on. Okay. Let's go to our existing whiteboard. Okay. I want to show you what the distance is. Let's hold on. Now, let me now let me look at this. That it's A is here, this is point B is here, and an object is moving from here to here. Either an object is moving from point A to point B. This is a distance D. This is a distance D. This is a distance D. Different distance between A and B. Point A and point B is the distance. So that's the distance. That's the distance. But immediately you now make this distance directional. Are you seeing the board? Are you seeing the board, please?
Yes, sir.
Immediately you now make this distance, you now give it a direction. I deliberately put it this way because I'm still going to introduce direction later. To give direction, it has another name, and I'll go back to the name you have later. So let me close the screen and go back to my teacher. Now, if you talk, and I want to discuss what's called displacement. Yes, you are behind the word internal displacement, internal displaced people, IDP, and so on. Internal displaced people, IDP. If you say something is displaced, it means there's an occurrence that causes a movement from one location to another. Well, either voluntarily or involuntarily, there's an occurrence that has caused movement from a location to another. That is clear. But still, let's not discuss displacement. Displacement is purely a change in position. Like that diagram I just gave to you now. If Mr. Q is at location A, and something happened, whether a force acted on that Q or not, and Mr. Q now changed location from location A to location B, that is a displacement. That's what? A displacement. But you call it a displacement. You call it displacement because it has a direction. We could have said Q covers a distance. Yes, but we didn't say that. We said Q had a displacement from location A to location B. Let's go to our whiteboard. Let's go to our whiteboard. Let's go down. Put it on the whiteboard. Good. let's say we have an object Q here. Right. All right, wow. A pen right eye is putting there. Oh God. That's all right. Something like that. Cool. Let's say our Mr. Q here leaves this place and comes to this point here, to point B here. Good. If Q moves to relocate from point A to point B, it means Q has been displaced from location A to location B. We're not just considering this distance D again because of the change in movement, change in direction, change in location. Though a distance has been covered, fine, there's no crime. A distance AB has been a distance AB has been covered by Q. But it has a direction. It has a direction. Because it has a direction, then it becomes a displacement. It becomes a displacement. Are you with me? Are you with me? Are you with me?
Yes,
Yes,
sir.
sir.
God bless you. Let's now look at Mr. Jackson, you're welcome. Jackson, you're welcome.
Hello.
Chicken, you're welcome to the class.
Yes, sir. Yes, sir.
Welcome. Mute yourself, please. Jackson, mute yourself. Chicken, thank you. Now, let's now go to velocity now. Look at the first one we described is just displacement. Now the velocity. Velocity V is the rate of change of displacement. The rate at which displacement occurs. How? May we not be kidnapped? I want a resounding amen. People are not saying amen to that phrase.
Amen.
Amen. Amen.
Anybody who has been kidnapped before will know that this is something. So not happen to us in Jesus' name. Now, there's one Manuel, put yourself. Manuel, sir. Now, there's something you must know. When kidnappers are operating, and that's why they look offensive somehow, as if they cannot be apprehended, as if they can't be apprehended. No, it is because if they are in location A, if you are tracking them in location A, in this location, they quickly move to location B. Immediately you are trying to locate them in location B, they move again to another location, to location C. To location C. As you're trying to track them in location C here, they again move to another location, which is location D. Now, I'm going somewhere. That is why it seems as if those who are perpetrating evil in our environment, they are not traceable. They can be located. No, they can be located. We move simple devices and little coding. But because they change their location so often, immediately they make a call to you that demanding for ransom, they leave that location, they move to another location. When they call you again, they are in another location. And they understand what is called handshakes of our communication technology, which means they have a new handshake, they know that they are in another location. They have devices they carry with them too. So when it now comes to velocity, velocity is the rate of change of displacement. rate of change of displacement from location A to location B to location C, then to location D. But no, it can be like that. So the rate at which those displacements are happening is what is called the velocity. And it has an expression. It has what? An expression. Velocity are equal to the v over the t, change in velocity, all over the t, change in time. That is the acceleration that will come from it. If you are accelerating, change in velocity all over change in time. But if you are looking for the velocity itself, that would be somewhere. If you are looking for the velocity, that would be that would be which velocity is equal to change in distance, all over change in time. Change in distance all over change in time. That is the velocity. You now want to go to acceleration, which is equal to change in velocity all over change in time. I will explain this. This d that I've written here can also be expressed as this. I'll give you my notes. Don't worry. I'll tell you why distance changes. If you're looking for velocity, I have told you that it has a direction. Acceleration has a direction. That is a distance, has a direction. Displacement has a distance, has a direction. But now that you want the velocity, you will change in distance all over change in time. That is ds over dt. Acceleration is dv, that b is velocity, and dt, that is change in time. And what we have discussed so far is motion in one direction. What we have discussed so far is motion in one direction. What we have discussed so far is motion. So what I thought is motion in one direction. Motion in one direction. Let's now look at motion in multidimensional, in multi-dimension. Motion in multi-dimension. That means motion in 2 or 3 dimensions. Motion in 2 or 3 dimensions. We're going to look at it. But before that, let's do something. Let's do something. Yes, there is velocity. Yes, there's acceleration. Sometimes when you drive a car, you hear people say, I just accelerated and I moved. Are they really accelerating? That's the question. Are they really accelerating? What's acceleration? Acceleration is the rate of change of velocity. And what is velocity? Rate of change of displacement. That means from one location to another, one location to another, one location to another. Let's now consider something I want to show to you today. I'll give you a secret now that you must learn. All of you have been watching videos, right? Have you been watching videos?
Yes, sir.
Sir.
Yes.
Watch videos. I will tell you, every video you watch, are you aware that there are pictures that you're watching?
Yes, sir.
Yes, sir.
Tell me if you know. I want you to tell me. Why do you say yes, sir? Why do you say yes, sir? Why do you say yes? Justin, why do you say yes? Justin?
Yes, sir, because videos are made of pictures.
They are made up of picture frames. Say that?
Yes, sir.
Say that. Say it again. Say it again. Repeat after me.
Yeah. Okay. Videos are made of picture frames.
Frames. Say that.
Picture frame.
No, that's what I said. Videos are made up of picture frames. Say that.
Videos are made up of picture frames.
God bless you. Thank you. Now mute yourself. Now, every video you see, that is, they are making use of displacement. They are making use of displacement. They are making use of velocity and acceleration. I'll tell you why. Every video camera, what it does is that it's taking several pictures at the same time, but from different directions. Listen carefully. When you hold up to the camera and you think you are recording videos, no, that camera is snapping pictures, collecting picture frames, though in quick succession at various locations and directions at time. When those picture frames are now combined together, they become a video. That is why most of the time, when you go to virtual referee on the pitch of play, when you're global football, virtual referee or the referee assistants, whatever they call it, they will go back to that video and they will trace the particular picture frame that identifies what has happened. Are you with me? Are you with me?
Yes, sir.
Good. You see that? I'll show you something now. I'm holding this pen. You are seeing the pen as straight. The same pen, I'm still holding it. Are you seeing the pen? Can you see the
Yes,
pen?
sir. Yes, sir.
Yes, sir.
I'm holding it. The same pen, I'm still holding it. The same pen, I'm holding. Still holding the same pen. And I'm still holding the same pen. And the same pen I'm holding. At every direction I'm holding this pen, the camera is collecting the pictorial frame of this pen at the various directions and positions. When those frames are now put together, they run when they're now effective. You see them as videos. And if peradventure we want to know the sequence at which I held this pen before it became a video, you will now break down the video into those picture frames. That's when you will see slow motion. When I was young, I used to be a village boy. We would say that anytime they give us slow motion of any film or any video or even on a football match precisely, we'll be thinking, how were they able to bring back this slow motion for the goal scored? We never knew that videos are collections of picture frames. And what happened was that there was a measure of displacement and rate of change of displacement and rate of change of velocity. They have considered the displacement of this pen. We have considered the velocity of displacement of this pen, and we have considered the rate of change of velocity of this pen. That gives us what we call videos. Now, let's now look at motion in 2 or 3 dimensions. Motions in 2 or 3 dimensions. I'm going to go into that, and we're going to look at something. Let me look at something again so that we'll see it. We'll look at I'm playing the whiteboard for you so that you can get what I'm saying better. Okay. Now let's look at something. Let's look at something. We want to consider motion in 2 or 3 dimensions. Let's look at position vector R. Position vector. My handwriting. Let's look at position vector R. Are you with me? That position vector R, it has an arrow on it on top like this. It's not be too clear, but don't worry. When I give you my notes, you have it clearer. Just listen to my lecture and enjoy it. Let's say x of I plus u of I. I'll tell you why they carry that caret. Talk of them, don't worry, I'll tell you. U, then z. Yes. Letter z of I, all of them. Here. This. Right? Good. All right, good. This formula here, or let me how can I start from here? You know the possible, but tell you don't worry. This formula I put on the screen for you here is referring to position vector R, which is telling us that considering x, I put one, there's an I there. There's an I here. There's an I here. I'm pointing something. There's an I here. Look at it here. There's an I here. There's a J here. There's a K here. But all of them are describing the position vector R. This is the position vector R, which is having a direction on top. From this equation, Chikenom, please tell us whether this is
Yes, sir.
whether this is scalar or not. Tell us if it's scalar or not. Chikenom, I'm waiting. Is this scalar or not? If Chikenom runs away, success. 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 Are you with me?
Yes, sir.
From this position vector I wrote on the screen, this equation, is it scalar or not? Is it scalar or not? Something to run away. Okay, Emmanuel, see your answer. Go ahead. Emmanuel, go ahead. Emmanuel, go ahead.
Yes, sir. Okay, I think it's vector.
Vector. Good. Mute yourself.
Be-
Mute yourself. Good. You got it. It's vector. But why is it vector?
Because it's moving on a straight line, which means it has a direction.
Manuel, I didn't want you to answer. I said, if you want to answer my question, you raise up for my class. Mute yourself.
Sorry, sir.
Thank you. You're welcome. No problem. Blessing. Blessing. Are you there?
Yes, sir.
Yes, I want you to answer my question. Emmanuel already answered that this is a vector. And I ask further question. Why is it a vector? Go ahead, answer that question.
Well, it's a vector because it's moving in one direction.
One direction. The typical answer is that there is a direction. Say that clearly, please.
There is a direction.
Good. Scalar has no direction. But in this case, this position vector, there is a direction. And that is the arrow on top of that letter out there. That arrow move showing a direction. That means there's a direction. So it's not a scalar. Not a scalar. Not a scalar. Are you with me? Thank you. Now, okay. I want you to know something. That the position vector, what value does it have for us? Does it have any value or not? Every position vector is doing something. And what it does that it describes the position of a particular of a particle in a space. Every position vector describes the position of a particle in a space. Now, when you carry your phone, if you use all these phones, I don't know. I think Samsung does that. When you carry these phones in your hand and you are moving from one place to another, you discover that sometimes the screen light of your phone just come up. You didn't touch the phone, but the screen light of the phone will come up. It's only signaling that there's an handshake, your position has changed from where you are, and that the station you are hanging on to before has been changed from one station to a new one, and it's shown. But on smartphones, you see Elisha A1 masts. Suddenly to change to Elisha not 2 masts, or to Ayegbaye mast 1. They are only telling you that there is a particle in the space and it is in this so and so position. And what does that? That keeps that position in the space, that keeps to monitor a particular particle in the space is what we refer to as position vector. I want to get you thinking that what can I do? This lecture you are receiving this morning, you can invent something. What can I do to solve a particular menace in this country? Go and be thinking when you get back home. With the lecture I'm giving to you this morning, I want to let you know that every particle in this space is traceable. Every particle in this space is traceable. And if every particle in this space is traceable, then why can't we as a nation trace terrorists, trace kidnappers, trace devices that can cause havoc? Yes. it is doable. Be thinking, get yourself thinking, put on your thinking cap, and think that with position vector, what can I achieve with it? It's possible. Let's now do something. From the beginning of this lecture till now, we have mentioned and discussed the fundamental concepts of classical mechanics. We have mentioned kinematics. We have mentioned dynamics. We have mentioned statics. And I've told you that kinematics describes motion without considering its causes. I've also mentioned to you that dynamics describes motion and forces that is causing that motion. Dynamics describes motion and forces that is causing that motion. While statics studies forces in equilibrium. While statics studies forces in equilibrium. We also went further to describe kinematics, talking about scalars and vectors. We described scalars, we described vectors. We went further to discuss motion in one direction, where we mentioned displacements, we mentioned velocity, we mentioned acceleration. Then we went further to discuss motion in 2 or 3 dimensions. Motion in 2 or 3 dimensions that gave back to position vector, where I was able to inform you that every particle in the space can be described by its own position. Every particle in the space can be described by its position with the head of a position vector. Now, I want to ask you simple questions, and I want you to answer. And I will note those who are answering my questions in the class. 1. Jackson has left. Okay, and this is Jackson again. Chicken up. I want you to describe.
Yes, sir.
Jackson is back here. Okay, Jackson, I want you to describe kinematics. Describe kinematics. Unmute yourself. Describe kinematics. Jackson, waiting. Jackson? Jackson? Are you there? Jackson, are you there?
Sir, kinematics.
Describe
Yes,
kinematics.
sir.
Yes, go ahead. You have.
Sorry, can you hear me? Hello?
I'm waiting for you.
Kinematics is a branch of classical mechanics that describe the motion of points, objects, and systems.
You see, each time I give you a question, and you take out your time to go and do Google and give me the answer. Now, put on your video, Jason. Jason, put on your video. Jason, your video. Jason, your video. Jason ran away when I said you put on this video. He ran away. Emmanuel. Emmanuel, describe kinematics.
Shield.
Emmanuel, go ahead. Emmanuel, you joined, you ran away. Emmanuel, go ahead, describe kinematics. Emmanuel. Okay, if Emmanuel is not answering us, Blessing, go ahead and describe kinematics. Blessing,
Sir.
go ahead and activate your video. When you answer my question, activate your video.
Okay, sir.
Describe kinematics.
Sir, kinematics, it actually describes the motion without considering the motion.
No.
Sorry.
Motion. No, you missed something. Take it easy, my dear. I believe in you, blessing. Go ahead, don't disappoint me. I believe in you. Go ahead. You were with me all through. I believe in you. Go ahead. Kinematics.
Okay. Kinematics are
describe the motion.
Concepts that describe the motion.
Good.
Without considering them.
Without considering what I said. Without considering what said.
Without considering the motion.
No.
Such as scalar quantities and
said kinematics considers the motion, but describes the motion. Kinematics describes the motion. You are correct. Kinematics actually describes the motion. Your video, blessing, don't go away. Your video. When I'm talking to you, I want to see what you're doing. Kinematics describes the motion. With me, without considering what causes that motion. Without considering what causes the motion. Blessing, are you with me now?
Yes, sir. Without considering what causes
the motion, but it does not consider what causes that motion. That is kinematics. Have you listened correctly?
Yes, sir.
Blessing, read what you are looking for to me now. I want to listen. Say it again.
Kinematics describes the motion. Kinematics describes the motion without considering what causes the motion.
I give it to you, you got it right.
Thank you, sir.
I'm happy with you. Now,
thank you, sir.
Emmanuel, Adasa.
Please mute so I can answer. Mute so that I can answer. Yes, sir.
I want to see.
You've not muted it. Let me see.
Dynamics. Describe dynamics. Dynamics. What do you understand by dynamics? Dynamics?
Is it muted?
Adasa.
Yes, sir.
What do you understand by dynamics?
It describes emotion and forces applying on them, or forces acted on it.
Again, I want to listen. Say it again. Dynamics does what?
It describes.
It
describes emotion or forces being acted on an object.
Manuel, look at me. Look at me. You're looking at me.
I'm looking at him.
I'm your teacher. Look at me. Now, describe dynamics. You got it. You got it. Huh?
Yeah.
You got it.
Dynamics is a motion, and it describes an emotion or a force exerted on an object.
Mute yourself. Mute yourself and listen to me. Dynamics describes motion and the forces causing that motion. Dynamics describes the motion and the forces that is causing that motion. Unlike kinematics, that only concerns itself with the description of the motion. Kinematics is concerned itself only with the description of the motion, while dynamics concerns itself with the description of the motion at the same time as the forces causing that motion. You can also say the forces acting on an object to cause the motion. Now I'm on to Chicano. Manuela, are you there? Manuela, are you there? Emanuela, are you there? Okay. Chicano, are you there? Jackson, you're back? Jackson?
Yes, sir.
Okay.
So I'm here.
Yes, sir.
Okay. Jackson ran. When I asked you to show your video, you ran away. Chicano?
Yes, sir. Yes, sir. I'm
Good.
here.
I have a question for you. Describe statics. Describe statics.
Sir, can you repeat what you said?
Describe statics. Statics. Describe statics. I'm waiting for Chikeno. Blessing, I saw your hands up. I'm not calling you yet. Blessing.
Okay, sir. Maybe it can be like when an object is in a state of.
See your video. I want to see your video.
Yes, sir. It's like.
Activate your video.
Okay.
You want to answer my question?
Okay, sir. Can you see me?
This your teacher here. I'm an IT expert, so you cannot cheat me. You can't be reading your Google search to me. I must see your face when you want to answer my question. Okay? Are we having that rule of operation? When you want to answer your questions, I must see your face. And you must be looking at me. Chicken up, you're not looking at me, I'm not seeing your face.
Yes, sir, I'm here now, sir, I'm here.
I'm not seeing your
yes,
face.
Sir.
I'm seeing your face. Your face is what I want to see. Aha, better now. Chicken up, describe.
Sir, my video is on, sir.
Describe statics.
It's when an object is in state of equilibrium.
Yes, statics is what? I'm not asking you to tell me this. I want to ask you what is statics?
What is statics?
Okay, it can be defined as a force acting on an object.
No. Statics is the study of forces in equilibrium. Statics is the study of forces in equilibrium. Statics is the study of forces in equilibrium. Statics is the study of
Okay, sir.
in equilibrium. Have you gotten that? Chicken up. Have you gotten that?
Yes, sir.
Yes, sir.
Now repeat what I said. Repeat what I said.
Yes.
Sir, what did he say?
Hey, are you in this class at all, Chicken? No? You're not in this class.
I'm in the class, sir. It's breaking this network.
You are not in this class, my son. You're not in this class. Not in this class. Jackson. Blessing, don't raise your hand. I don't want your hand up. Adasa, I don't want your hand up. Jackson.
Yes, sir.
Success, go ahead. Success, go ahead. And I will see your face.
Okay. Can you see me?
I can see you. Go ahead.
Okay.
Yes, sir.
You talked about statics, right?
I said describe statics.
Okay. I think it's an object at rest or a free zone, like
I'm waiting.
at rest.
What is
So
statics?
like, yes, I said, I think
5 times.
when
I said it here like 5 times, but I asked you again to say it again. That time, Chikenon was not showing his face. He wanted to hide somewhere, but I didn't say I didn't agree. Okay, Jassy, you are back. Describe statics. Mood and success. Jassy, describe statics. Blessing, put down your hand.
Statics. Okay.
Put down your hands. Lower your hand. Jassy, describe statics.
Yes, sir. So statics is like an act, the force acting on an object.
No, I didn't agree. Yeah, there are forces truly. Statics, there are forces. Fine, it's the study of forces. But what type of forces? What type of forces? Success. Take it from there. Success.
hello, sir. Yes, sir.
Yes, there. I'm listening to you.
Yes.
Go ahead, but I want to see your face. I've been
That's
distributing
it.
from Google.
Okay.
Success, yes. And I answer my question. What is describe statics? Describe statics.
Okay. Like
I
I said that.
said it to you earlier before now. I gave it to you earlier before now. Even in the course of asking this question, I've said what statics is many times. Statics is the study of forces in equilibrium. Statics is the study of forces in equilibrium. Statics is the study of forces in equilibrium. Success, write that down. Statics is the study of forces in equilibrium. Statics is the study of forces in equilibrium. Success,
Yes, sir.
is what I've said that you wrote down.
Okay. You said statics is the studies of force in equilibrium.
Say it again.
Statics is the study of forces in equilibrium.
Good. Clap for yourself. Clap for yourself. I've not had you clap.
Okay.
Clap for yourself. I want to hear you clap. Success, clap for yourself.
Yes.
Good. Good. Now, I think everyone has gotten that description of statics. Can I take your yes?
Yes, sir.
Thank you.
Yes, sir.
Thank you. Thank you. Why is Chicken on? He ran away.
No, sir, I'm here.
Chicken don't run away. He's always running away.
Sir, I did not run away.
Okay, are you with me? Then describe statics. Chicken describe statics.
Statics can be defined as the study of forces in equilibrium.
You are right, correct. Clap for yourself. Let me see your video clapping for yourself. I will see your face. Chicken, I must see your face. Good. Clap for yourself now.
Sir, can you see my face?
Let me see hand clapping for yourself. Chicken, you do not clap for yourself. You must clap for yourself before I let go of you. Better.
Sir, can you see my face?
Better. Good. Now, Jason. Jason?
Yes, sir.
Jason?
Yes, sir.
What are scalars? What are scalars? Describe, let me see your face, Jason. I must see your face. That's the standing rule. That's the rule of engagement. Listen, everybody. The rule of engagement in this class is that when you're answering any of my questions, I must see your face. It's a must. Okay? Deal?
Yes, sir. Sir, can you see my?
That's a deal?
Yes, sir.
Go ahead, Justin. What are scalars? Justin, what are scalars? Justin, run away. I must see your video before you answer my question. You cannot hide. Justin, what are scalars? You want to go and Google search? Justin ran away, Google searching. Okay, blessing. See your hands up. Take it over from there.
Okay. Sir, scalars are quantities with only magnitudes.
Just say scalars are quantities without direction. Say that.
Scalars are quantities without directions.
Scalars are quantities without direction. Say that again. Say that again.
Scalars are quantities without directions.
I love that better. Thank you. God bless you. Success. Give example, please. Blessing, lower your hand. Success. Give example of scalar quantities.
Okay, sir.
Example of scalar quantity.
Mass.
Example of scalar.
Distance. Okay, mass.
Example. Blessing. You want to say something? No, I'm not allowing you. Adasa. Example of scalar quantity. Adasa.
Speed.
What? Say it
Speed
again.
is an example of scalar quantity.
Correct. You're right. You're correct. It's you. Justin. Give another example of scalar quantity. Mute yourself, Adasa. Mute yourself. Justin. Another example of scalar quantity.
Time.
Time. You are correct. Can you give another example?
Distance. Distance.
Distance. That's correct. God bless you. I give it to you. Thumb up.
Yes, sir.
Thumb up. Said that answer my question. You said that. Blessing, you want to say something? I can see your hands up. Blessing. Blessing, I saw your hands up. Okay, thank you.
Yes, sir.
Chicken on. Chicken on.
Yes, sir.
What are vectors? What are vectors? What are vectors?
Vectors
Vectors
are quantities that have magnitude and direction.
See your face. See your video. Go ahead.
I can see my face. There are quantities that have magnitude and direction.
Somebody. What is telling you what to say?
No, sir.
Let me
No, sir.
Let me explain myself to all of you. I'm a teacher. I'm not a lecturer, so I would naturally get all your antics. So, and you must learn in my own class. I have a set goal. My set goal is that every student in my class must learn. And I'm evaluating what I've learned now. That's why I'm asking questions. So, chicken up. Chicken up. What are
Yes, sir.
What are vectors? Be looking at me. Be looking at me. No other direction. Look at me. Don't look at any other direction. Me.
Okay,
what,
sir.
You know.
Okay, there are quantities that have direction and magnitude.
There are quantities that are having both direction and magnitude. You are correct. You are correct. You are correct.
Thank you.
Adasa, give an example.
Yes, sir.
I must see your face before you talk. I must see your face. And that's I must see your face. Give example of a vector quantity.
Displacement, sir. Is hanging. I mean, it's not the phone.
Mute yourself.
Yes, sir.
Jason. Jason. Jason.
Yes, sir.
Your video and then give an example of a vector quantity.
Sir, can you see my face?
An example of vector quantity.
Force.
What?
Force.
First,
Yes, sir.
I don't agree. Give a better example of
Displacement.
displacement. Adasha said that earlier. Say that one.
Velocity.
You're just making trial and error, or you got it. Yeah, you're right anyway. Velocity is an example of a vector quantity. But why is it an example? Why is velocity qualified to be an example of vector quantity? Just why is velocity qualified? Just don't go away. No, you cannot go away. I must see your face. Jason, I must see your face.
Yes, sir.
Why do you categorize velocity as a vector quantity?
Sir, because it has magnitude and direction.
How do you know the direction in velocity? Look at me, don't look elsewhere. Don't look elsewhere. Just look at me and looking elsewhere. See, I'm with you here. Look at me, my face. Looking at my glasses.
Yes, sir.
Anyway, that's all right. That's all right. You can mute yourself. Just you can mute yourself. That's all right. That's all right. Success. Success.
Yes, sir.
Give an example of a vector quantity. Don't mention anyone that I've mentioned. Though.
Acceleration.
You cannot be radio. You cannot be radio. You must be ready. You cannot to answer the next question. So I did not say anything.
I said acceleration.
So that you said that's correct. But why are you afraid of saying it? But it's correct. It's correct, you got it right. Thank you for today, our first lecture. I enjoyed all of you, and I'm happy you're my students. I'm happy to meet you. I did not introduce myself earlier. My name is Dr. Aki Akiyele. My name is Dr. Aki Akiyele. That's my name. So, all of you will now introduce yourself one by one to me now. Before I'll now give you take-home job, take-home assignments. This is one by one. Starting from Emmanuel. From Emmanuel Adasa, yes? Introduce yourself, Emmanuel Adasa.
Okay, sir. My name is Emmanuel Hadassa. I'm from Adamawa State.
You're from Adamawa State.
Yes, sir.
That state where you came from, that state was in the former Gongola state. That state happened to be in the former Gongola state. And that was where I served in 1999.
Wow.
Gembu, in 1999. You know a place called Gembu? Have you ever heard the name Gembu?
Gable, no, sir.
You see, that place is in the demo. God bless you. Success, introduce yourself. Success.
Yes, sir.
Your name?
I'm Success Window.
You are what?
Success Window.
Success who? I can't hear the second name.
Window, Alban. Success Window, Alban.
I had success, but I didn't hear others.
Chiwendu, Alban.
You are success Chikwendu. Al
Yes.
Al
Ban. Yes, Alban.
Albans. Okay, maybe I will get it.
Yes, Alban. Yeah.
Maybe I'll get to pronounce the name correctly sometimes. Anyway, no problem. Jason, your name? Jason, your name?
My name is Jason Adebayo.
Your name is what?
Jason Adebayo.
Jason Adebayo. That's all right. Chikeno, your name? Introduce yourself. Chikeno.
My name is Chikenum.
Your name is what?
Chikenum.
Chikeno. Chikeno who?
Chong.
Say your full name, please. Your full name.
Okay. Chikenu Echong.
Chikeno Michong. Okay, that's all right.
Yes.
Blessing, introduce yourself.
My name is Elijah Blessing Desire.
Which state?
I'm from River State.
From Rivers State. Okay, where in Rivers?
I'm actually from Ahoda.
From where?
Ahoda West.
Ahoda West, that's all right.
Yes, sir.
Have you heard about Ukwa Ebrutu before? I've been to Ukwa and I've been to Ebrutu.
Sorry, you said?
I said I've been to Ukwa and I've been to Ebrutu as well in Rivers.
Okay. Ukwa and Ibudu. Ibudu.
I visited Ukwa and I visited Ebrutu. So,
Okay. Sorry.
Yes, go ahead. Go ahead.
Is it you visited? Is it the community Ukwa?
Yes, community Ukwa, yes.
Okay, okay, sir.
Another community, Ebrutu.
Okay, okay, sir.
Places I visited in Rivers.
All right, sir.
I visited all the states in this country, all of them, all the states.
That's very encouraging.
So you can learn something from what you have taught today, but don't forget, position better, think about it, and think about what problem in Nigeria can you solve with position better.
Okay, sir.
That's the take-home assignment for all of you. What problem in Nigeria that is staring us in the face as Nigerians and as a nation and as a country developing? What problem in Nigeria can you solve if you actually study and understand classical mechanics with particular emphasis on position vector? God bless you. I'm going to end the introductory class at this time so that we'll meet again next week, where we're going to take it more advanced. And you're going to have slides from me by the grace of God. Then we'll share my screen. Any question for me? Any question? Any question for me? Chikeno, Jason?
Sir, please, sir. Hello, sir.
Yes, success.
Sir, please, can you please repeat the assignment again? I didn't get it.
The assignment is looking at Nigeria as a nation and our current challenges as a nation. What can you achieve with the deployment of position vector? Looking at Nigeria as a nation and our current challenges, what can you do? What problem can you solve deploying position vector? Have you gotten it now?
Yes, sir.
Yes, sir.
Thank you. Any question for me?
Yes, sir.
Any question for me? Any question for me? Any question for me?
No, sir.
Okay. Thank you. We'll come to the end of this class. The class is recorded and you can listen to it again and again. God bless you.
Sir, hello, sir.
Sorry.
Say what, sir? Go ahead.
Yes, sir, please, how about the notes?
I'm going to get it across to you.
Okay, sir.
Be sure you are getting all my notes. But I said, notes, you get my notes per class.
Thank you, sir.
You get my notes per class. Is that clear?
Yes, sir.
Let's see you.
Yes, sir.
Bye-bye. See you next class. I think I'm going to take you to the next class as well. We'll be dealing with algebra. Are you aware of that?
Yes, sir.
Are you aware of that?
Yes, sir.
So
We are lecturer.